Say something.
Hello, everyone. Good morning. If you can hear me, kindly identify. Thank you. All right, thank you. I'm Embassy Marshall. I'm the AI lead. First of all, would like to apologize for the delay so far. We had a technical glitch with the sound, but we've been able to rectify that. I wish to apologize for that. I will actually be doing a brief introduction before we start the class for today. Once again, my name is Embassy Marshall, and I'm the AI lead. So we have 5 different modules for the AI program. Module number 1 is Introduction to Machine Learning, and that's what you'll be taking today. And the facilitator for this is Miss Khadija. Miss Khadija would actually take each and every one of us on the Introduction to Machine Learning, after which by the next month, we'll go into Deep Learning Basics, and then we'll have real-life model development and optimization. And that will be taken by Dr. Charles. After which we would have building AI-powered chatbots without programming. I'll be the one facilitating that particular topic. And then we have a capstone project at the end of it, which I will also be the one to handle that particular session. I would like to indulge us to take this serious. AI is actually a very vital part of every growing economy currently, and the knowledge of AI is quite very important as well as expensive outside. If you are to go take a course on AI outside, it ranges into hundreds of thousands to a million plus, and having an opportunity to take it here for free is something we all should take serious. So I would like us to take this training serious, and also note that you all will be examined and will have to take a test as well as do projects, of which will be used to rate your performance and your whole activity throughout the whole session. For those that would like to join the class live at Bayes University, some persons are here, some are not. We understand there was an issue with the last timetable, and we do apologize for that. But for those that would like to join in live at the location, we'll still be here next week, Friday, and you can still join online as well. All right, with that being said, once again, my name is Embassy Marshall, and I will be handing over to Miss Khadija to actually continue for today. Thank you very much, and let's pay attention to the class. Miss Khadija.
So good morning, everyone. So my name is Khadija Mohammed. I'm a lecturer here at Bayes University, and I teach the AI course. So for this semester, for this particular module, I'm going to be teaching the fundamentals of machine learning. Under that, we have Introduction to Machine Learning using unsupervised learning, supervised learning, and reinforcement learning. So we'll go through that within the next 4 weeks. So Introduction to Machine Learning, these are the course contents. We have introduction, types of machine learning, and then under types of machine learning, we'll go through supervised learning. We'll look at common algorithms. We'll see how we can evaluate model performance for machine learning. We'll see how to prepare data and engineering features. So first, what is machine learning? So it's a field of study that enables computers to learn from data and make predictions or decisions without being explicitly programmed. So if you've used programming languages before, you'll know that you need to write different if statements. So you'll say, if this happens, you need to do this. If this happens, you need to do this. But with machine learning, you just need the particular data and the output, and then it will help you with the rules. While in the traditional programming language, you had to write the rules. So machine learning is just a subset of artificial intelligence, which helps the computers to think for themselves. So we want computers to be able to act like humans, though we're not there yet, but we're getting there. And so machine learning should be able to generate rules for us. So in the classical programming, what we did before was we would give it data and rules, and then it should get us answers. So for example, we will say, if this happens, go here. So if, for example, someone enters a particular gate, what should you tell them? So that was the programming languages of before. So for example, if you log in, you can say, okay, welcome here. But with the machine learning, what we want to do is give it the data and the answers, and we want it to give us the rules, how to get from a particular input to an output. So that is the major difference between machine learning and the normal classical programming you know of. So we have different types of machine learning. So the first one here is supervised learning. In supervised learning, the algorithm learns from labeled data, making predictions or decisions based on that data. So basically, it's like having like a teacher guide you through a certain task. So let's say you want to be able to say, okay, are these pictures cats or dogs? So at first, you will need to show that particular model, okay, these are pictures of cats, and then it should help you get cats. So with supervised learning, it's more like having a teacher guide you through. While with unsupervised learning, you're just going to give it different data, and then it should then separate that for you. So you should be able to find patterns yourself. So this we'll have next week. We also have reinforcement learning. Reinforcement learning involves training algorithms to make sequential decisions by rewarding or penalizing its actions. So, so here you teach by giving rewards or penalties. So for example, if you're training somebody and okay, they are doing very well, you want to reward them. But if they are doing very bad, you want to give them penalties. So that is reinforcement learning. So we'll take this in week 3. So now let's get started with supervised learning. So supervised learning involves training a model on a data set with labeled example. So where each example consists of input features and a corresponding output. So for example, imagine you're trying to predict whether a student will pass or fail an exam based on their study hours and previous scores. So in this scenario, the input features are the study hours and previous exam scores, and the output is where the student passed or failed. So you can use supervised learning to help teach that particular computer what it should do. So you have the particular input. So does the student read? How many hours have the students read for? And then you also have their previous exam score. And with this, you can now know, will this student, you can try to predict if this particular student will pass or will fail based on their previous score or how long they read for exam. We also have something like predicting the price of a house. So let's say you have different data about houses. For example, you have their size, the number of bedrooms, the year it was built, and so on. You could use these particular inputs. So for example, size, number of bedrooms, to say, okay, how much is this house going to cost? So for this particular house, you can say, okay, 10 million naira. Let's say it gets bigger, you can now say 20 million naira and so on. So you can use this to help predict the size of a house. Let's say you also have features of, okay, these are cats and these are dogs. So you can give it input of, okay, cat images, dog images, and then you can tell the computer, okay, this is a picture of a cat, and say this is a cat. You now give a picture of a dog and say this is a dog. So what the machine learning algorithm should do is learn the rules that make that particular cat a cat and that particular dog a dog, so it can predict for you. classify for you. So we have common algorithms with supervised learning. So we have linear regression. Linear regression is a straightforward algorithm used for predicting continuous values. It works by fitting a straight line to the data, aiming to minimize the difference between the observed and predicted value using techniques like least squares. So what this means is it's trying to predict a value from a wide range. So for example, like price of a house. So you have the size of the house. So how many square feet is this particular house and what price would it be? So let's say it's 1,000 square feet. You can say, okay, this is going to be 10 million naira. 2,000 square feet can be 20 million naira, and so on. So what linear regression aims to do is to try to fit a line, so like this on the board, that can fit through a set of points. So let's say the below line is the size of a house. The line below is for the size of a house, ranging from 0 to 1. And that's for the x-axis. And for this y-axis here, let's say this is for the price of a house. So for this particular size here, that let's say it's 0.1, you can now estimate it to be 1.5 million naira. So this is just what linear regression is trying to do. So you want to be able to say, okay, for this particular, you have data, and for example, for this particular house, this is the price. For this particular house, this is the price, and so on. And at the end of the day, what you want is to fit a line through these points you have. So that anytime you want to get the price of a new house, you can come here. Let's say you want to check for 0.7. All you need to do is trace this line up here to the line and trace it back left this way. And you can say, okay, this particular price is 4.7. So that is what we have with linear regression, just for continuous values. So another example is also the study hours. So let's say a student has studied for 4 hours. So you can estimate, okay, their score in exam can be 60%. If they study for 5 hours, 70%, and so on. So these are just examples. But linear regression is basically to predict continuous values. So for example, the price could range from 1,000 or 10 million naira to 100 million naira, and so on. And then for the study hours, for the score of the exam, it can range from 0% to 100%. So we also have something like logistic regression. So it's a widely used algorithm for binary classification tasks. It estimates the probability that a given input belongs to a particular class using a logistic function. It's particularly useful when the relationship between the features and the target variable is linear. So for example, let's say you want to be able to classify emails. So you know how you receive emails and some of them may fall in spam and some of them may be in the normal inbox. So it can be able to get certain features that can make an email spam. So those emails that are spam are, for example, okay, buy this wristwatch for 10,000 naira. This job here is 10,000 naira. Get this job for free. Get a job without working, and so on. So some of those things might be spam. So it should be able to get certain features that, okay, will make a particular email spam or not spam. So that is logistic regression. So anytime you get an email, you should be able to classify, is this spam, is this not spam? So like yes or no, 0 or 1, something like that. Then we have decision trees. So they are just capable of handling both classification tasks and regression tasks. So you want to split data into different subsets and feature values. So let's say you want to, so in this decision trees, for example, you're just going to ask a series of questions. So let's say you want to say, okay, is this fruit an apple, for example? It will say, okay, is this fruit round? Is this fruit green? And so on. So it is just going to keep answering yes or no till it gets to the final output. So for an orange as well, it could say, okay, is this fruit round? Is this fruit green? And so on. For mango, you can ask a series of questions. Is this oval? Is this circle? And so on. So depending on the answers, yes, no, and so on, it will form a tree to get to that particular output. So with decision trees, you can be able to say, okay, what kind of fruit is this? With k-nearest neighbor, so it just predicts the target value of a new instance by averaging or voting among the k-nearest neighbors in the feature space. So let's look at our housing example for now. Let's say this house is, you want to know the price of this particular house. So it is going to use the k houses among it. So let's say you say k is equals to 4. It will use 4 houses that are close to that size of the house and try to predict the price of that particular house you're looking for. So that is what k nearest neighbor is. So k is just the number you use to predict the price. So you have this particular laptop, for example, and then you will now say, okay, among the 5 laptops with this similar specification, what is the price of that? And then you can now know the price you sell that new laptop for. So that is k nearest neighbor. You're using different neighbors, k different neighbors to try to predict something or classify something. So anytime you're using machine learning, you want to test that particular model to see how it is doing. So for example, the spam or not spam, let's say you show the system 100 spam emails. So how much is it able to get correctly? And there are different types of metrics you can use to understand that. For example, accuracy, so the proportions of correctly classified instances. So let's say you have, for example, 100 spam emails, and the system is able to correctly say 80 of those emails are spam. So that means that's an 80% accuracy because it got 80 out of 100 correct. So that is accuracy. How much did it get correct? What percentage of data did it get correct? And we have precision and recall. So we'll go through this more next week. So precision is just about how much, let me say it's trying to predict spam. So how much of those spam are actually spam? And then we recall among all your spam emails, how much did it get correctly as spam? Then we have F1 score. So it's helping you combine both precision and recall. With the ROC curve, it also helps you draw the trade-off of the true positive and false positive, which we'll go through again next class. And AUC will also give you a score that's for the true positive and false positive rates, which we'll go through next class. So let's look at machine learning again. So it's data-driven. So first, one thing you can do is collect data of images and their labels of classes. So machine learning, you need data. So if you look at this particular image here, let's say you're trying to build a system that can help you classify if an image is a cat, dog, mug, or hat. One thing you do is create your data set or get different images for your data sets, right? So you can say, okay, let me have 10,000 different images of a cat. Let me have 10,000 different images of a dog, 10,000 different images of a mug, 10,000 different images of a hat. Because we are trying to classify this as either cat, dog, mug, or hat. So we need images of them. So then you can now use one of the machine learning algorithms to train this to be able to get a classifier. And then one thing you should do, so when you have your data set, instead of using all of the data, you want to only use some to be able to train, and then you leave out some for test. So it's like your normal class, for example, when the teacher is teaching you, it might give you this particular example. And then after that, the teacher will give you a different example for you to try on. The teacher will not give you the same example. So for this particular one, if our data set has 10,000 images of cats, 10,000 of dog, 10,000 of mug, and 10,000 of hats, one thing you can do is take 70% of cats and give it to the system, 70% of the dog images, give it to the system, 70% of the mug, 70% of the hat, and give it to the system. So it will now teach this particular model, this particular classifier, that, okay, these are pictures of a cat, and it will tell it these are actually cats. So then remember it left out 30%, right? So the system only saw 70% of the images when you are training it. So training just means, okay, that is what you're showing it. So for example, you give the system an image of a cat, and you say this is actually a cat. You give the system an image of a dog, and you tell it this is a dog. You give it an image of a mug, tell it this is a mug. Give it an image of a hat, tell it it's a hat. So that is training it. You're showing it. So one thing you can do is use 70% of your image for this, and then the remaining 30% that you did not use, you now use it to test. So the ones the system did not see, will now be used to test to see, okay, has it actually learned something? Because if you give it the one it has seen, it will be able to give you the correct answer. But you want to give a different image, and you want to see, okay, is this the correct answer? So that is why you have to split your data set between training and testing. So you can use 70% of your images to train, and then 30% to test. So you can now test this classifier on a different set of data, including the ones used for training, and then you can use this evaluating here, model evaluation, to try and see how well your model is doing. So for example, let's say you give it, so let's say you have, let me say 3,000 images that you did not give your system, and that's what you want to use to test, 3,000 images of a cat. So among those 3,000 images of cats, how many did it get correct? And that means removing errors and inconsistencies from data. So with cleaning, let's say in your table, remember how like for example, Excel looks. You might have, okay, a sheet of saying, okay, these are students' scores, these are their performance of last semester, and so on. So anytime there's a missing value, you want to know what to do. So that's part of cleaning. So anytime there's inconsistency, you might want to remove that particular row. We have transformation. So transformation simply means scaling or normalizing features to ensure uniformity. So let's say you have, for example, let's go back to our housing price example. You have number of bedrooms, and you can have size of a house. So let's say the number of bedroom features is between 1 to 5, and then size of a house, let's say, is between 1 to 2,000. You can see that 5 and 2,000 are very far apart. So one thing you might want to do is bring the values together so they can be of similar range. If not, the one of the size is going to overpower the one of the number of bedrooms. So you want your features to be similar. So this is what we'll see during our workshop. We also have encoding. So just converting categorical variables into numerical representations. So for example, let's say you have gender as one of your features, like male or female. You might not be able to read male or female, so you might want to change that to 0 or 1. So you can use 0 for male and 1 for female. We also have feature engineering. So this is creating new features or transforming existing ones to improve model performance. So for example, let's say you have height and weight of a particular individual. You can use height and weight to get another feature, which is BMI, because from height and weight, you can calculate someone's BMI. So that's adding another feature, and that can help build a robust model. So we'll also look at common problems later on, so like bias, variance. So for example, with bias, you want to make sure your system is doing good while when you're training it, it's not really learning correctly. And when your system has high bias. We also have high variance. So with high variance, let's say you're training it, it is learning very well, it is fitting to the particular data, but when you're testing it, you will now find out, okay, this did not learn well enough. And with that, you can also get the overfitting or underfitting. So when you have high bias, that is underfitting. The model is too simple and we'll want to have other things. And we also have overfitting. So models the training data too well, but fails to generalize to new data. So that's like having high variance. It is when it's training, you can see it is learning specifically to that training set. But when it comes to testing, it is not doing well. And we'll look at different strategies that can help us address this over. So on conclusion, we went through the basics of machine learning, and we went through the types, algorithms, evaluation metrics, data processing, and common problems you might have, pitfalls you might have. And so understanding this fundamental is crucial for building a strong foundation in machine learning. So just a summary, so machine learning, it's not like the classical programming where you give it data and rules. So with machine learning now, you're giving it the data, for example, pictures of a cat, and you're going to tell the system this is actually learn the rules to get from that particular image to the outputs. So that's one thing about machine learning. And with machine learning, you need to split your data set because you want to know how well it is doing. So for example, you can say you use 70% to train, that is, remember, to teach the system. So you're giving it the input and you're giving it the answer to it. So, and then it should learn the rules. And then with a separate data, so remember splitting. For example, you can use training, 70% to train, and then 30% to test. So after you train, the remaining 30 with 70%, the remaining 30% you did not use, you can now use it to test to see how well the system is doing. And there are different evaluation metrics, which we'll go through next class, and also the data preprocessing techniques. So I'll go through some different questions that were asked on the classroom. So for example, we have one from Abdulmomin Ibrahim. He said, please, can we still use multiple regression analysis by using more than 12 bedroom? Okay, yes. So with multiple regression, so this simply means you have different features. So for example, for the size of a house, if you want to use the size of a house to predict the price, with size, that means you only have one feature, but you can add more features. For example, number of bedrooms, number of years, and so on. Number of floors as well. So when you have like different features, that means you have multiple features. So, and yes, you can use 12 bedrooms, but make sure you scale your data down. So like, for example, if you have 0 to 12 bedrooms, and let's say the size of your house is 1 to 5,000, you might want to normalize. Let's say you might want to change everything from 0 to 1. So your data set will have 0.1, 0.2, and so on. So we'll see this during our lab. And also, Isaac Chima asks, can this be done practically for us to see how all of this works? So yes, so the lab work, the lab notes and so on will be given to you on your platform, on the Telegram platform, and next class will start our labs. So one thing you should do is go through the notes and familiarize yourself with all this so the labs will look easy, will be easy for you to learn. Then Mansour Sadiq, I heard that logistic regression is also called classification supervised learning. Is that correct? So yes, so logistic regression is also classification. So you can use binary classification for this. So with binary classification, you can classify between, for example, yes or no, 0 or 1. So that's like having two different classes. So for example, the one with the spam, remember we were trying to see, is this spam or not spam? So for example, yes or no. So that is classification. So logistic regression is also called classification. So that one you want to have two different values, like binary classification or discrete values. So while with linear regression, you have continuous values. So that will range from a particular range of values. So you don't have a particular class you want to fit into. But with classification, you have a particular class you want to get, either yes or no, 0 or 1. But if you're trying to predict someone's age, it can fall in 5, 6, 8, 15, 20, 35, and so on. So another question from Olaifa Emmanuel. So where or when do you use time series analysis? So for example, let's say you're trying to say, okay, for this, how much ice cream will they buy at a specific time? So let's say you have an ice cream data set, or you want to sell ice cream. So you will know that, for example, during the winter, for example, you might sell ice cream less, but during the summer, you sell more ice cream because it might be hotter. So that is when you can use time series data to predict that. Okay. So at the moment, Ibrahim also asked, can you make any of them like number of restroom be independent? Okay, so yeah, so if you want to predict, okay, you want to use only bedroom, right? So you said you want to use bedroom for regression. So you just need to remove the size feature and then say, okay, if this house has 5 bedroom, how much do you think the price will go for? If this house has 10, how much do you think the price will go for, and so on. So, but when you have more features, you'll be able to build more robust model. So, for example, when you want to get size of the house, you know it would be best to use different particular values like size, number of bedrooms, number of years, and so on. Sorry, I'm waiting for the next question. Okay, so yes, another question here. And some people classify their data into three: training, testing, and validation. So yes, so we will learn about the validation data set as well. So with when you split your data into, like, let's say 70% training, 30% testing, from that 70% training, you can also use some percentage for validation. So validation just simply means while you're training, what can you also keep testing while training? But with the test set, after you finish it, that's when you use your test sets. So in the last week, we'll look at training, testing, and validation, 3 different data sets. But basically, the training is to teach it. Validation, while you're training, you can be asking different questions. So let's say it's, for example, teacher students. You can give them different examples first. As you're giving them different examples, you also want to test their knowledge as well. Let's say at the end of the class, you can have workshop, or during the class, you can have workshop. While with the testing, when you finish the class totally, you want to see how well the particular students are doing. So training, teaching, validation, just basically testing while training, and then testing when you finish the whole training, then you want to test it at the particular level. Okay, so then for the next question. So someone asked about the predictions. For example, if they get 95% accuracy, is this good? So one thing you can do is see what other people have done. So get different results from other people and see how well their system is doing. So if they have, let's say the sample result is well. So if they have 95% on a particular work, you might okay, try with other techniques to see how you can get 97% accuracy. We'll also look at prediction as well in the next lab. basically based on, so that was another question. So basically based on the weather from yesterday and the day before yesterday, can you predict the weather for tomorrow? So that's also the time series. So yes, you can use multiple regression, so that you can have different features to help you predict a particular answer. So, for example, the size of, to predict the price of the house, we use size, number of bedrooms, year of the house, and so on. And to get a good accuracy, if you want to know if your accuracy is very low, you can check other research papers to see if it is doing well. And you can try different techniques to also improve the accuracy. So we'll see different techniques in labs in 2 or 3. Okay, so I think that was the last question. So that means I'll send the lab notes to you, and then also this particular lecture notes, and then you can try to summarize it.
Okay, everyone. Thank you, Ms. Tanisha, for that. For those of you complaining about the cloud noise, that's one of the students here on site. So if there's nothing we can do about that, we apologize for that as well. I've seen questions regarding if this is for AI. This is actually the AI class. This is not for cybersecurity and this is strictly for AI. I will let Mr. Marcos actually explain the timetable change and every other thing. Then we call it a day after that. Yes, Marcos.
Okay, thank you very much for all wonderful teaching this content and also the big coordinator on AI as I ever see. My name is Oluwaseun Marcos, the object administrators for the Ideas program. I just want to inform you all that your departmental classes have started. This particular class is strictly for those doing artificial intelligence, AI. So this is not GST. This is not GST. This is AI class. So it's basically for AI students, those who put in for AI. And if you have those who are in other various departments, which is cybersecurity, business intelligence, software engineering, and all that, please kindly check the timetable. I've shared it on the Telegram group. There's an updated timetable. You go there now on the Telegram group and check the timetable. People say I don't hear me very well. It's okay now. Can you all hear me now? Please, I want to get feedback from you. Is it clear now? Is my voice clear now? Okay, so kindly go to the Telegram group and check the updated timetable there and know when to come for your class, especially those who actually opt in for the physical class. Know when to come for your physical class. So we are going to be having another class after this, which is have to do with those in blockchain, which is the blockchain department. They're going to have their class after this. So please, those who are for physical class blockchain, we all expect you to be here. And because we know that some of us didn't get the updated timetable information on time, so you are permitted for today if you can't join us physically, but ensure you join online. But I know by next week, everything will fall into place. So ensure you join online for now. And please make sure to go to the Telegram group and check all the messages, the information that have been passed on the Telegram group, so to know how you can go about your lectures. And regarding to your LMS dashboard, kindly note that very soon it is going to be updated. Those who are in various departments, your dashboard is going to be updated, those for AI, those for cybersecurity, so that you can also join the class and take your attendance right from your dashboard. So right now, we are not going to be taking attendance for this particular class because it's only just streamed on YouTube. So there's no way to take attendance. So those asking for attendance, there is no need for that for this class for today. So going forward from next week, we have a way we can take attendance for those who join the class. So kindly note that this is your departmental course, not GST. So I don't want a situation whereby people will be thinking it's a GST class and they won't come for their physical class. It is now time for your departmental course. So those who opt in for physical class, please come for physical class for your courses. So that's all for now. So any information, please, you can send it to me on Telegram. We will share more information on the Telegram group.
All right, thank you, Mr. Marcus. Okay, everyone. So the attendance is actually very important. So if you are to come for an on-site class, please do well to be there. And for those that are online, do well to attend the classes too. Kindly note that your attendance is part of the criteria for your qualification. And also, I'm still seeing questions on if this is for cybersecurity and the rest. This is strictly AI. This is for AI, artificial intelligence. It's not a general class. It's not for cybersecurity, but AI. Apply for change of course. Those that apply for change of course, kindly send a mail directly to the ideas mail, or you send a message to Mr. Marcus, the admin on the Telegram group. They'll follow up from there. This is a class channel, so we can actually answer that question here. Data analytics, when are they having their class? Kindly check your Telegram group for the timetable. I think the timetable has been updated on the Telegram group. Check there for your timetable. Check the Telegram group for the timetable. This is, I repeat again, AI. This is strictly for AI, not for any other course. This is AI. For those that change their courses and wants clarity on anything, you should mail ideas directly, or you talk with Marcus in the Telegram group. He will give you an update on that. So with this, I believe we've come to the end of today's class. Like I said, your attendance is quite important, and you'll be doing projects. You have a capstone project. You have other projects. You have a project with Miss Khadija here for this first set. You have a project with Dr. Charles, and then you have a capstone project at the end of the whole training, of which you will have to take, and your qualifications, your certification will also come from your performance. Now, the next class is on Friday. AI classes is on Fridays, every Friday from 10 in the morning. If you are coming to base, come to base block C. Block C, Base University classes is from 10 in the morning. If you are streaming on AI classes, to send a mail, or you go to Telegram. On attendance comes for this class, either online or on site. We are taking attendance. Akintola, we will take attendance from everyone that comes for the class. Or on site, we will take attendance for that, each and every one. You can join the class online. You can join the class online. The capstone project, you all will be expected to carry out the project, as it should be used to rate your performance. We've come to the end of the class for today, so we'll see you again next week. Khadija will take you again by 10 o'clock on Friday. Day. If you have more questions or challenges, please send it to the Telegram group. The Telegram group link. Please, Marcus, please share the Telegram group link. Asking for it. So the Telegram group link will be shared. For those asking about attendance, your attendance is going to be taken care of. So the next class, those that are up for the. So this is the end of AI for today. She stopped by 10 o'clock. Thank you very much and have a great day. Okay, for those asking for the Telegram link, it has just been sent. You've seen the Telegram link there. Join the Telegram page that's the link. So for those asking, that's the link for it. All right. Thank you very much and have a great day.